Hello, and today we are going to be doing the Unit 4 review for your test that is coming up. As you can tell, this girl is very excited about the test, but it's because she hasn't reviewed yet, and then she'll be excited. Okay, so first we are going to start off with the equation of a circle is x minus 4 squared plus y plus 9 squared equals 49. What are the coordinates of the center of a circle? Okay, so the first thing that we have to remember is that a circle is in the form x minus h plus y minus k squared equals r squared. Okay, so the center is hk, and then the radius is r right there. So that tells you the radius of the circle. All right, so if you notice here, the formula is minus x minus h, y minus k. And the center of the circle is a positive h and a positive k. So whatever is in this parentheses right here, okay, if it's a minus, that means that your answer is positive. If it's positive, that means that your answer is negative. So for example, on this one, since the inside the parentheses here, since we have a negative 4 and a positive 9, okay, that means we're looking for a positive 4 and a negative 9. So we know that the center of the circle is at 4, negative 9. All right, this one says, in the following circle, the measure of arc AB equals the measure of arc CD. What is the measure of angle AFB? So we want to know the measure of this angle right here. Okay, so what we have to do first is look at the given information. So if you notice here, we have an inscribed angle. So remember, an inscribed angle is an angle that has all three of its points on this circle. So we have the two endpoints and the vertex is on the center of the circle. Okay, that's an inscribed angle. And then here we have a central angle. Okay, a central angle has its two endpoints on the circle, and its vertex is the center of the circle. All right, so that's the difference. A central angle, the vertex is in the center of the circle. An inscribed angle, the vertex is on the edge of the circle right here. And so what we know is that an inscribed angle is half of the arc. So for example, if the inscribed angle here is 32 degrees, then we know that the arc, we're going to double this. Okay, 32 times 2 is 64. So we know that this arc is 64 degrees. So now, since we know that this arc equals this arc, we know that this arc is 64 degrees. Okay, and then the next step is that we know that the central angle equals the corresponding arc. So we know that the central angle now is 64 degrees, and that is what the question is asking for, the measure of angle AFB. So we know it equals 64 degrees. Alrighty, on this one we want to know what is the measure of arc AC. So we want to know the measure of this arc right here. Okay, so if we look, right, what we first notice here is that we have an isosceles triangle. Right, we know this because we have two sides that are equal to each other. Okay, and that's what an isosceles triangle is, two sides that are equal to each other. And if you remember, the isosceles triangle theorem says that the opposite angles are also congruent to each other. So for what we need to find out now is what are these angle measures? Well, first of all, we know that a triangle adds up to 180. So what we're going to do first is take 180 minus 44, and that's going to tell us how much we have left of that triangle. So we take 180 minus 44, and that gives us 136 degrees. Okay, so we know 136 plus 44 equals 180. If these two angles equal each other, okay, we know that they have to add up to 136. So we're going to take 136 and we're going to divide it by 2. So that means that each one of these angles equals 68 degrees. Okay, so now if you notice, arc AC right here actually has an inscribed angle right here, angle ABC. Okay, notice how I made a cone right there? See, there's my cone, and then there's the ice cream that's on top. All right, so remember earlier we talked about inscribed angles are half of the arc. So if we know that this inscribed angle is 68, then we know that the corresponding arc is going to be 68 times 2, which is going to be 136 degrees. So that would be the measure of arc AC. Okay, on this one, we are going to name all the secants and tangents for circle C. Okay, so remember a secant is a line that touches a circle at 2 points, and tangents are lines that touch a circle at 1 point. All right, so if we look here, okay, if we look at line AD right here, it's neither because it's not touching the circle at all. Okay, if we look at line AB, it's touching the circle one time right here. So line AB is going to be a tangent. Okay, so let's just make a column here. We'll say tangents, and then down here we'll say secants. Okay, so AB was a tangent, okay? And then if we look here at BG, okay, BG touches the circle in 2 spots. So BG is actually going to be a secant. If we look at HC, okay, line HC touches the circle in 2 spots. So line HC is going to be a secant. And if we look at line GE, right, if you notice here, it actually touches the circle in 2 spots, okay, on those 2 little spots right there. So line G, oh, actually, I'm sorry, that's wrong, because that line is actually just showing that they're intersecting, okay. This dot right here is showing where line BG intersects with line FE, okay. So this one's actually not touching the circle. So this line FE is actually just touching the circle right here. Okay, so we can put FE up here under tangents. Okay, and then remember AD was nothing. Okay, and then here's this question. Are any of the above chords? All right, now remember a chord is a line segment. All right, remember a line segment has a beginning and an end. So a chord does not have arrows like this, okay? A chord then would have to have an endpoint on the circle, all right? So it would be like that, all right? These right here would be examples of chords, okay? They don't go on past the circle, all right? So that's the big difference right there. Chords have their endpoints on the circles, okay? Whereas secants are lines that touch the circle at least twice, and then they usually go through the circle. Okay, this says that line TP is tangent to circle R, and we want to know what is RT. Okay, so the first thing that we know here is that it's tangent. All right, so one of the things that we know about a tangent line, if a line is tangent and it intersects a radius, then it makes a 90-degree angle. So we know that this angle right here is 90 degrees. What that tells us is that this triangle is a right triangle. So in order to find RT, okay, what we would have to do first is find RP right here, okay? And so we are going to use Pythagorean theorem for this one. Okay, so if you notice here, they gave us RS, okay, and they told us that it's 10. All right, the reason that that helps us is because it also tells us what RP is, because RS is a radius and so is RP. So if RS is 10, then we know that RP is 10. So now all we have to use is the 10 and the 24 and plug that into Pythagorean theorem. Okay, so remember we're wanting the hypotenuse here. Okay, we're wanting RT. So we don't really even need this 10 now. The reason this 10 was here, again, was just to give us this, this side right here. So we're wanting the hypotenuse, so that's the C. So we're going to plug in 10 squared plus 24 squared equals C squared. Okay, 10 squared, 10 times 10 is 100. And then 24 squared, which is 24 times 24, is 576. So then you're going to add 576 to 100, which is 676. And remember, it's been squared here, so we want to take the opposite, which is square root. So if you take the square root of 676, you get 26. Okay, so line RT then equals 26. Okay. Now, you could take this a step further if it was, let's say it had asked you to find ST instead. Okay, you still would have had to do this whole problem right here. You would have had to, and then there would be one extra step in knowing that this was 10, right? So if we wanted to know what ST was, then we just take 26 and we subtract 10 from it. And so ST then would equal 16. Okay, so here what we want to do is write the equation of the circle for the given graph. Okay, so remember what we talked about earlier. Our formula is x minus h plus y minus k equals r squared. Okay, where hk is the center of the circle and then r is the radius. So if we look for hk, all right, h is the x and k is the y, right, x and y. So if we look here at our center of the circle, okay, it's -2, 2. So again, and I'll show you how this works, right? If we plug in x minus -2 plus y minus a +2, okay, a negative times a negative is a positive, so that's why it ends up as x plus 2. And then this one minus is just y minus 2. Okay, and then if we look here, the radius, okay, we're just going to count to the edge of the circle. So here's my center, and if I count out, I go 1, 2, 3. So that equals 3 squared. Okay, so to finish it out, we have x plus 2 plus y minus 2 equals 9. Okay, this one says the radius of circle N measures 25. Chord GH equals 40. What is TS? Okay, so we know that the radius is 25. Okay, so what that tells us is that all of these are 25. NE, LN, and NS, right? NS is going to equal 25. I'm going to write this over here so that we don't get confused on what we're talking about. Okay, here it says chord GH equals 40. Okay, now what we know about the chord bisecting theorem, okay, is that if a chord intersects a radius at 90 degrees, so that's why this is important here, okay, that it's showing you that it's 90 degrees. If it intersects a radius at 90 degrees, then it bisects the chord. That means that GT equals TH. So if we know that GH equals 40, that tells us that TH equals 20 and GT equals 20. Okay, so in order to find TS, okay, the first thing that we're going to have to do is find NT. All right, we know that GT is 20. Now here I can connect G and N together, and look, I've made another radius, right? So I know that this is 25. Well, now if you've noticed, I've made a right triangle. So I can use Pythagorean theorem to find side NT. Okay, I use a squared plus b squared equals c squared. Now here we have our c, right? Because the c always has to be the hypotenuse. So we have 20 squared plus b squared equals 25 squared. Okay, 20 squared, which is 20 times 20, is going to be 400. going to go down here. And then 25 squared, which is 25 times 25, is going to be 625. And then you subtract 400 from both sides, which is going to give you 225. And then you take the square root of 225, and that's going to give you 15. So side NT is going to be 15. So in order to find TS, right, we know that NS equals 25 and NT equals 15. So we just take 25 minus 15, and we get 10. So TS is going to equal 10. Okay. In this one it says, in circle F, the measure of angle AFE equals 90 degrees. Okay, so this is 90. And the measure of arc BD equals 20 degrees. What is the measure of angle C? Okay, so in this one, all right, we know that if you have two lines, okay, that intersect outside of the circle, all right, their corresponding intercepting arcs, all right, you can subtract them and divide by 2 to get this angle. All right, so on here, and I'm sorry, this is terrible. Let me erase this real quick because I should not have put those degrees so close because it makes them look funny. Okay, so we know this is 90 degrees, and then this is 20 degrees. Okay, much better. Okay, so if they intersect outside of the circle, then we know that we can take the arcs, subtract the arcs, and divide by 2. All right, so we know here if we have this, it's a central angle. That means that its corresponding intercepting arc is also 90 degrees, right? Remember, they equal each other. An inscribed angle is half, but a central angle is the same. All right, so now all we have to do is take 90 minus 20 and divide by 2. 90 minus 20 is 70. And if you divide 70 by 2, you get 35 degrees. So B should have been your answer. Okay, so this says, what of the following equations of a circle has a center of 6, -2 and a radius of 3.6? Okay, so remember our formula for a circle, okay? It's x minus h squared plus y minus k squared equals r squared. Okay, so the center then is at 6, -2. So remember, when you plug these numbers in, they're going to turn opposite, right? So we have x minus 6 squared, and then y minus a -2 is y plus 2 squared. And then we plug in 3.6 squared. Okay, so we have x minus 6 and y plus 2. Okay, so oh, and these should have said y. I'm sorry. Okay, so x minus 6, y plus 2, that could be 1. Okay, that's not 1, right? Because it says x plus 6, x plus 6. This one says x minus 6 and y plus 2. Okay, so here's 2 of our answers. So then we have 3.6 or 12.96. So remember, our formula is r squared. That means we have to square the 3.6. So your answer then should have been D. Okay, 3.6 squared is 12.96. Okay, so this one deals with translating. Okay, we're moving it. It says the circle described by the equation x plus 6 squared plus y minus 2 squared equals 3.6 is shifted to the left 4 units and up 2 units. What is the new center of the circle? Okay, so the first thing you have to know is the old center, right? And so here, if we have a positive 6, that means that the center is at -6. And if we have a -2, that means the center was at +2. All right, if we're moving it to the left 4 units, all right, left and right is your x, okay? So if we're moving it to the left, that means that we're going negative, okay? So we're going to take -6 minus 4, which is -10. Okay, so if you actually look here, negative 10 is only C. Okay, now, but let's go ahead and check our answers to make sure. The other thing that it said to do is move it up 2 units. So remember, up and down is your y. Okay, if you're going up, that's positive y. So you're going to take 2 plus 2, which is 4. Okay, and if you look at C, it does have positive 4 as your answer. Right, this one says line ET is tangent to circle A at T, and the measure of arc TG is 92 degrees. What is the measure of angle GET? All right, so we're wanting this angle measure right here. All right, so it tells us that the measure of arc TG, okay, right here, is 92 degrees. Okay, the reason that that's important is because if you notice here, we have an inscribed angle, right? It has all 3 of its points on the circle. Okay, remember an inscribed angle here, this angle is half of the intercepted arc. So what we're going to do here is we're going to take 92 and we are going to divide it by 2, which is going to give us 46. So that gives us 46 degrees for that angle. All right. It also tells us that this line is tangent at T. Okay, so remember, if a line is tangent, okay, to a radius, okay, which is here is a radius or a diameter, okay, because radius and a diameter are the same, we know that it's 90 degrees. Okay, so that tells us that angle is 90 degrees. So we have 90, and I'm going to go ahead and erase this other, this 92 right here, because we're done with that. Okay, so we know that this is 90 degrees. We know that this is 46. So we're going to add 90 plus 46, which is 136. And we're going to subtract that from 180 because we know that a triangle adds up to 180. And that's going to tell us that angle GET equals 44 degrees. Okay, on this one, we want to draw the graph of a circle with the given equation x plus 2 squared plus y minus 3 squared equals 16. Okay, so again, remember our equation. We have x minus h plus y minus k equals r squared. All right, so our x, okay, is negative here, positive. Okay, so that means it's opposite. So that means we go negative 2. Okay, that's our center, negative 2. And positive 3. Okay, so we would graph that. So we're going to graph the center, negative 2, positive 3. Okay, so we know that's where the center of the circle is. Okay, here we have this equals 16. Okay, that tells us a little bit about the radius. So remember, the radius here, okay, the equation is r squared. So that tells us that r squared equals 16. So we actually have to take the square root, and we get 4. Okay, so what that tells us then is that the points of our circle are 4 away from the center. So we can go up 4, 1, 2, 3, 4. Okay, that would be one part of the circle. Then we can go over 4. And then we can go down 4. And then we can go to the left 4. Okay, so if you notice, this is what makes your circle, these 4 points on the outside. So you would just connect your dots, and you would have your circle. Okay, I think, yeah, this is the last one. All right, it says circle A has a radius of 10 centimeters. Arc BC, CD, DE, and EF are congruent. Okay, so all 4 of these arcs are congruent. What is the approximate length of arc DE? Okay, we want the length. All right, so remember when it's asking for length, it's wanting the answer in radians. Okay, so remember the length of an arc equals the measure of the arc, right, in degrees, over 360 times 2 pi r. Okay, so remember the measure of the arc is going to be in degrees. Okay, so the first thing that we have to know here is that if that this right here, line BF, is our diameter. Okay, so it divides the circle in half. So what that tells us that that this semicircle, right, BCF, this big semicircle right here, is 180 degrees. So in order to find the measure of one of these arcs, then we're just going to take 180 and we're going to divide it by 4 because they all equal each other. So what that tells us then is that arc DE, okay, in degrees measures 45 degrees. So I can plug in 45 over 360, and then I can take it times 2 times pi, and then it tells us that the radius is 10. Okay, so now I'm going to erase this so that I can. Okay, so now what we're going to do is just solve all this out, right? Because we just want the approximate length. You don't even have to worry about reducing it and see how, just multiply everything out and then divide it, okay? We can take 2 times pi times 10, and let's just take 2 times 10 first, right, which is 20. And then we can take 20 times 45, which is 900. Okay, so we actually have 900 times pi over 360. So now take 900 times 3.14, which is 2,826. And then we're going to divide that by 360. And that's going to give us 7.85. So again, that's an approximate, right? Because we use 3.14 per pi. So it's approximately 7.85 in, centimeters. And when you're expressing length, you always use whatever unit is given to you. So here they gave us centimeters, so that would be the unit we would use, 7.85 centimeters. Okay. If you have any questions at all, please don't hesitate to call me, email me, send me an IM, and I will be happy to go over more of this with you. Individually or in a group or whatever you need. If you don't understand something, please ask before you take the test, okay? I hope you have a great Thanksgiving break, and I hope you do well on the test.